Thanks. Not really, but anyway. So I'm Zender. I, together with Gert-Jan Netjes, who could be here for the workshop itself, with Ariane, who is over there, and Adriana, who is over there. We arranged not the first spectral workshop. Actually, it is, if I'm not mistaken, the second spectral workshop, but it might be the first kind of laboratory hands-on spectral workshop. And it was so much work to prepare the workshop that I said, no, I don't prepare another presentation. So I will leave this to two of the participants, Yoshi and Norton, and I hand over.
Thank you, Joe. Thank you very much. Good morning, everyone. My name is Jószef Vinkó. Together with Norton, we are from Konkoly Observatory, Hungary. And first of all, many thanks to the organizers of this spectroscopy workshop. It was extremely useful, so please give them a loud applause. Thank you very much. So I don't know how to move forward. All right, so these were the aims of the spectroscopy workshop. And as you can see, we learned a lot. I don't have time to go into all the details, all the technical details, so let's move to the results. This is the equipment that we used as a laboratory practice. You can see that this is quite sophisticated. So it contains, where is the laser? Okay, here. So it contains a light source, which was both a laser and an LED, a tunable LED with RGB bands. And here you can see the grading. We had several gradings that we could switch and test. And all working groups got a grading and they tested the spectral and dispersion properties. This is the camera. We had different versions of cameras, more expensive ones, cheaper ones, so we could also test and compare the results. And all the electronics, Raspberry Pi and all these things. Okay, and this is an especially important high-tech anti-reflection device that was installed one of the group members at the site. So we actually did, yes. So we actually did a technology development during the workshop. All right. Okay, so this is an example LED spectrum of an LED source. When I first saw this, it was quite disappointing. But then I learned that, okay, it is not surprising because this was made by a holographic grating film, which is not the best quality at all. But it does the dispersion. So you can see the blue and the green part. The red part is missing, probably due to the camera sensitivity. Okay, and yeah, and as you can see, this is the 0th order, so it is undispersed. That's the image of the light source itself without any dispersion. And these are the so-called first order dispersed spectra on both sides of the 0th order. This is the well-known property of transmission grading. Okay, another example. This is much better. And here you can see the second order as well. First order, second order, even the third order is visible. So that's much better grading. Still a grading film. Okay, and here I give the microphone to Norton and he will explain the rest.
Thank you. Morning. So you can see here the intensity that we got for some of the filters. The first and second order are visible, and some of the bar charts here. And basically what you can see is there are some symmetrical gradings that we used, but there are also very unsymmetrical, and I have no idea what happened here, to be honest, why the 0th order is lower, but there are symmetric and asymmetric parts here, which is expected, so it's not surprising. As you know, there are grading types that will produce not this, but this asymmetric distribution here. Then we had some interesting tasks or experiences. First of all, there were 2 types of teams. So 4 of the 6 teams had a color camera, and 2 of them had a monochromatic camera. So we tried whether we could use the color camera as a monochromatic. So just turn it to gray and let's see the results. You can see the same camera in color mode and in monochromatic, and you can already see that some of the peaks are lower here, which is also expected, that you cannot really use it this way, because here is the gray intensity of the same spectra. Here's the RGB, and you can see that in red here or in blue here, it's already clipping, which is nowhere to be seen in this one, and that was explained deeply by Peter Slansky at the workshop. So if you want to learn about color mixing, he can give you a quick 2.5-hour lecture on the matter. The other team was busy on analyzing the spectrum of a light source, actually a handheld lighter, which was put under a bucket. It was amazing. You have to imagine it because I didn't take any pictures, but I hope at the end of the conference there will be pictures about this beautiful phenomena. We had a nice code which was put together by Joe to analyze the spectrum. It got improved during the workshop, so not only hardware but software development were made during our time. Here you can see the actual spectra of this one, and this is a monochromatic, so there is no problem with the RGB. We also tested, just because we had some times, the infrared TV remote and whether the spectrum would change in RGB and in gray, but there was no difference, which means that all the color filters that are in front of the sensor are see-through in infrared. So that way there was no difference at all there. We had some exercises left. So we got to exercise number 2 out of 9, which is a good thing because it means that we learned a lot, and that also means that if Joe and the team decides to make another workshop, they will have to think less because they already have some exercises left over. So it was great. Thank you so much for the experience, and thank you for the team who put together the workshop, and thank you for listening.
Okay, thank you. We have 1 minute for some short question or maybe 2 questions. No question?
That's good because I don't have answers.
Okay, so thank you all speakers again.